Hello, so this video is going to focus on rationalizing denominator if we have a radical or if we have a complex number, right? We need to rationalize the denominator, and simplifying complex fractions, so fractions like that, when we have a fraction within a fraction, right? Like this one or this one. Alright, so first let's rationalize. So to rationalize the denominator, we cannot just multiply here by a square root of 3, because if we do, then this here, that square root of 3 would have to be distributed over, and we'll still have 1 in the denominator. That wouldn't be helpful. So what we need to do instead is multiplying that denominator by its conjugate. So what is the conjugate of 2 minus square root of 3? So first of all, let me rewrite that. So 2 minus square root of 3, and we are going to multiply that by its own conjugate. That will be 2 plus the square root of 3. Remember, a conjugate is when you keep the same two terms you have in the binomial, but if you have a subtraction, the conjugate has an addition, and if we had an addition, the conjugate would have a subtraction, right? But we're going to do that top and bottom because we have to keep the original fraction equivalent to itself, right? So we multiply top and bottom by the conjugate, and the reason we do top and bottom is because that's like multiplying by a 1, right? Anything divided by itself is 1, so that's multiplying by a 1, which doesn't change anything, yet it will help us to rationalize that denominator. Okay, this is a binomial multiplied by just one number, so we're going to distribute that. So 5 times 2 is 10. And then 5 times the square root of 3 is 5 square root of 3. Remember, that does not become a square root of 15, right? The number is on the outside here, so we're not going to multiply the radicand by the coefficient in the front. Now, the conjugate, however, are going to become... Now, if you don't remember how to multiply conjugate, I'm going to do the first one the long way, but after that, we're going to try to use the shortcut and remember them, okay? So the long way would be by just foiling, right? So 2 times 2 is 4. Then we'll have the outers, right? So 2 times the square root of 3 will be 2 square root of 3. And then we have a negative square root of 3 times 2. That will be a negative 2 square root of 3. And then a negative square root of 3 times the square root of 3 will be a negative square root of 3 squared. Let's extend that fraction here. So why do we like to multiply by the conjugate? Because then notice how the outers and the inners will give you the same two things, except one is positive, one is negative. They go to 0, right? 2 square root of 3 minus 2 square root of 3 goes to 0. That's always the case with conjugate. This is why I said we can use the shortcut and say, okay, we know that the outers and inners are always going to cancel when we multiply two conjugates, so we can just go and say it's going to be the first times the first. 2 times 2 is 4. And the last times the last. Negative square root of 3 times negative square root of 3 is negative square root of 3 squared. Okay, so let's simplify what can be simplified. So 10 plus 5 square root of 3 all over 4, and then a square root squared cancels, that becomes minus 3, and 4 minus 3 is 1, so that's just going to be 10 minus 5 square root of 3. So that will be our answer right there. 10 minus 5 square root of 3. I don't know if you can see that very well. 10 minus 5 square root of 3. Okay. Number 2. We still have a radical in the denominator, so we're going to multiply top and bottom by its conjugate, the conjugate of the denominator, because that's where we try to get rid of that square root, right? So we don't touch the numerator. We're going to keep it as 2 plus square root of 5. But we're going to multiply by the conjugate of the denominator. So the conjugate of 4 plus square root of 5 is 4 minus square root of 5. And we need to do that top and bottom, so it's like multiplying by a 1, right? 4 minus square root of 5. Because 4 minus square root of 5 divided by 4 minus square root of 5, that's just a 1. So we didn't really change anything. It's multiplying by 1. But it's going to help us rationalize that denominator. Alright. Now, up here we just had a number, so we could just distribute it. But here now we have a binomial multiplied by a binomial, so we actually have to FOIL, right? So first, outer, inner, last. So 2 times 4 is 8. 2 times negative square root of 5 is negative 2 square root of 5. Then the square root of 5 times 4 will be plus 4 square root of 5. And then square root of 5 times negative square root of 5 is negative square root of 5 squared. All over. And here now I'm going to use the shortcut, because remember we said the middle term are going to cancel anyway. So I'm going to just do 4 times 4, which is 16, minus square root of 5 times square root of 5, which is just going to be a square root of 25, which is just 5. Okay. This here is just going to become a 5, right? So that, let's write it above. Square root of 5 squared, that's just going to become a 5. So now I have 8 minus 5 is 3, and then negative 2 square root of 5 plus 4 square root of 5. So I have negative 2 of them plus 4, that's a positive 2 square root of 5, all over 16 minus 5, which is 11. And that's as far as it can be simplified. So there we go. Alright, so what is different when we have actually an I, a complex number? Well, we do the same thing. We use the conjugate of the denominator. So we're going to keep the numerator as is, but the denominator is the one we're trying to get rid of that I. So we rationalize it by multiplying by the conjugate of that denominator. So that becomes 1 plus 2i, but we need to do that top and bottom. So it is like multiplying by a 1, right? We call those the very well chosen ones. Okay, multiply, so it's binomial times a binomial, so we're going to have to actually FOIL. So 2 times 1 is 2. 2 times 2i is 4i. Oops, I forgot my plus here. Negative 3i times 1 is negative 3i. And then a negative 3i times a positive 2i is a negative 6i squared. So we're going to write it down first. All over. Remember, those are the conjugates, so we can drop the middles, right, because they're going to cancel anyway. So it'll be 1 times 1 is 1, minus, and then the last times the last, right? So 2i times 2i will be 4i squared. Now we have to remember something about I. I is really a square root of negative 1. So if I have an I squared, that's really a square root of negative 1 squared, which is really just becoming a negative 1, right? A square root and a square, they're inverse operations, they cancel each other. So I squared is technically really just a negative 1. So this I squared here becomes negative 1, and this I squared here becomes negative 1. So we have a negative 6 times a negative 1 becomes a positive 6, so that becomes plus 6. So we have a 2 plus 6, which is equal to 8. And then we have a 4i minus 3i, so that will be plus 1i. And then this negative 1 times negative 4 is going to be a positive 4, and 1 plus 4 is 5. There we go. Okay, so what do we do when we don't have a binomial? Like up here we had a binomial. Here it's just one term. Well, we can just go ahead and multiply by that I then, right? So I'm just going to go ahead and multiply top and bottom by that I. And that should do the trick. Because we don't have a binomial. It's just one term at the bottom. So we're going to distribute this I. So we have negative 3i. And then a 5i times I will be a 5i squared. And then down here we'll have a 15i times I, which is I squared. And remember we said I squared is equal to negative 1. So this here just goes to negative 1. And this here just goes to negative 1. So now we have a negative 3i plus 5 times negative 1, that becomes a negative 5. So I'm going to put the real number in the front, negative 5 minus 3i. And then I have a 15 times negative 1, which is a negative 15i. We don't like to leave the negative like that in the denominator, so I'm going to multiply through by a negative 1 everywhere. So that becomes a positive 5, that becomes a positive 3i, and that becomes a positive 15. And that will be it. This could be really broken into two fractions if you wanted to. You could write that as 5 over 15 plus 3i over 15 actually. And so now this could be simplified. 5 over 15 will be 1/3 plus, and 3 over 15 will just become 1 over 5, so 1/5 I. So that will be the same thing as this. Those two are the same, they're equivalent. Alright, let's go to the complex fraction now. So when you have a complex fraction, what you want to get rid of is the fraction within the fraction, right? So look at your denominators. We have a fraction here and a fraction here, and both of them have a denominator of x. Well, whoa, that's nice, because that means I could just multiply by x here and by x here. Multiplying top and bottom by the same thing is like multiplying by a 1, right? X over x is just 1, so I'm just really multiplying by a well-chosen one. And I chose that one to be x over x because when I'm going to distribute my x here, 1 times x is x, plus 1 over x times x, those x will cancel, will be 1. And see, now I don't have a fraction in the numerator anymore. And same in the denominator. 1 over x times x is just a 1 minus and then 2x. And that's all I wanted to accomplish, right? I wanted to simplify my fraction so I don't have a fraction within a fraction anymore, which we call complex fractions. We don't want that. So, and we accomplished that, so we're done. Alright, so now let's look here. Well, this one is a little bit different. And when I'm looking at that first, I thought, maybe I could factor that. So let's try that first. Let's see what happens. So we're going to keep this one as an x cubed over x plus 1. And I'm going to see if I can factor that denominator here. So x over, what can you multiply to give you a 1, but add up to give you a 2? Whoops, a 2. Well, 1 and 1, right? 1 times 1 is 1, and 1 plus 1 is 2. So I can actually factor this as being x plus 1 times x plus 1, which is x plus 1 squared. That being done now, I have a fraction divided by a fraction. Well, that's the same thing as my numerator fraction. Change that division to a multiplication, and now do the multiplicative inverse. So you're going to multiply instead of dividing by the reciprocal of that. So it becomes x plus 1 squared over x. Well, that's a multiplication now here. So we have x cubed divided by x. Well, those can be simplified to an x squared. And then I have an x plus 1 quantity squared divided by x plus 1. Well, those two can simplify as just an x plus 1. And that will be my answer. No more fraction. All right. I think that's enough for this summer review.